Right, so I'm just going to do a quick video on multimeters, just the basics. This is a basic multimeter, this is more advanced with more settings. It's got capacitance and temperature. But this one's got voltage, AC and DC, resistance, diode, continuity and 2 microamps. I'll go through all these settings except for the amp ones. I'll do a separate video on the amp, on the current. So basically we're just going to start with the voltage AC. So I'm going to test the mains voltage in this house. Just, you got to be careful when you're doing mains voltage testing. So straight away, made a mistake then. It should be on AC. Always make sure that you got your settings correct before you do it. Because if you're in the amperage range and you plug it in, you can burn your meter out or do yourself an injury maybe. So there you go, that's 240 volts. So 240 volts AC. So that's alternators, generators, mains electric, and basically alternating current means it's cycling between negative and positive, and it does that at 50 times a second, so 50 hertz. The mains does anyway, and so should generators. But anyway, that's I'll do a more in-depth video on each setting, but this is just a basic one. So I'm going to pull that out, I don't want to make another mistake. Change it to DC. DC is batteries and like AC to DC converters and inverters. So I'll just test on this battery. So basically you test voltages to make sure you got enough voltage and also that voltage is getting to the equipment. So they are useful tests. So anyway, that's 1.6 volts. So that's a fully charged battery. It should be 1.2. Well, it's a 1.2 volt battery, but they always read higher when they're charged, and it would be like 1.1 if it was flat. So as you can see, it's got a little line there. That means I've got the leads reversed. So if I put the negative to the negative and the positive to the positive, it will read, but that line will be gone, so you know that you've got the correct way around. That's useful for testing polarity. So that's voltage anyway. So I've got another example here. This is a battery from a camera. So that's just under 8 volts. So let's check what it is. There's a 7.4 volt battery. So I was saying that's nearly fully charged because it's 7.9 volts. I've also got the polarity the right way around, so if you reversed it, you get that line up. So if you go back, I now know that this one is the positive terminal. So that's a useful test. That's just another example of DC voltage. Right, so the next is this like omega sign, looks like an upside down horseshoe, and that is resistance. So basically all wires and electrical devices have a resistance, so you can measure the resistance and that will tell you, like this cable that I'm measuring now is really low resistance, like 0.6 or 0.8, so it's less than an ohm. And if you deduct the reading of the leads, which are 0.7, that's like 0.01 of an ohm, so really low resistance, as it should be. But if you've got like a heater element, like this is a heating element from a shower, you can measure the resistance of the element and check it against a workshop manual or a known good one. So that's 12.8 ohms. I know that's a good reading. And the second one is 12.6 ohms. So they're good readings. But you can also use it to check for wires, obviously. If you know the meter length what the resistance reading is per meter, you can work out the length of a wire. You can test elements, heating elements, bulbs, ignition coils, injectors. So being able to test the continuity, the resistance, getting a reading and checking it against your workshop manual, it'll tell you whether you've got a good piece of equipment. And I know that's a good reading, so this is a good element. That is a useful test. It's probably the one you use the most as well on a multimeter. So I've got some more resistances, just these little resistances you see on electronics. So you can test these. So that one's 38 kilo ohms, that's very high resistance. And that one's 36, so similar. Don't matter which way you have the leads round. All it's doing is sending the voltage from this cable to this cable and measuring the voltage drop, and then it calculates the resistance. So next is continuity, which is similar to resistance. It will give you a reading, but it also beeps as well. So you don't have to look at the screen. You can just touch it together, and if it beeps you know that you've got an intact wire. So I know without looking that that wire's good. Same with that heating element. Just touch it from one side to the other. I know that element's good. I know that it's at least intact anyway. So it's just a quick way of going through circuits and making sure that there is continuity. Obviously a direct connection between them. So just another quick example. We've got it hooked up through continuity to this micro switch, so you can test really quick whether the switch works. So the last setting on this one is diode mode. So I'm going to go back to diode mode. Diodes are in loads of things, in most electronics. Basically they allow current to flow one way but not the other. Some are set up so they let a certain amount of voltage through one way but not the other. And they're used in rectification mainly, or blocking electric, like a non-return valve. So basically you always have a diode mode on all meters, because you do a lot of these. So you should get voltage in one way but not the other. So there's nothing that way. Swap the leads round. And you should get a read, so there's 0.5. If it was going, it'd have a different reading, so you can check what sort of diode it is and make sure the reading's correct. I'll do another one. But they're in bridge rectifiers and all sorts. And transistors, you can use these to test transistors, but I'm only doing a basic video on this one, so. And that's it. That's diode, so there's no, the other settings are current, and I ain't got any way of showing you that today, so